Welcome. I'm going to go through some solutions, possible solutions for the backcountry project. That's the piecewise functions. And I'm just going to highlight some of the information that's in here. So, the first thing is what should the graph look like? And let's see if I can make this a little bit bigger. Your y-axis should be labeled as elevation. That's above sea level. And I don't have it here, but this should be in terms of feet, right? And then your x-axis is in terms of hours, it's time. And using the problem, we can figure out some of these. Like, for example, it starts from, I think it was 3,800 feet elevation, and it goes up to 5,700 feet. And note that there is a point at 3 because that's 3 hours into it, and then the elevation at the hut where you stop is 5,700. Also note that the assumption is that it's a linear pattern, as was stated in the directions. So this segment is going to be a linear segment. The next segment, right here, you'll notice in the text that it's 1 hour long, so from 3 hours to 4 hours, and this point will be at 4,700. The next segment will be after lunch going up to the highest point, which is an elevation that's another 1,000 feet at 6,700. This was another 2.5 hours. Or I'm sorry, 1.5 hours, going from 4 to 5.5. And then the last segment is the downhill, where starting up at the highest point, 6,700, down to the 3,800 in the parking lot. And you can, if this one is 5.5 hours, and the whole thing was 6 hours and 15 minutes, or 6.25 hours, you can see it's a 45-minute descent. And then from that, so that's what our graph looks like. And then from that, we can create a piecewise function here. The first function, I use point slope, 3, 5,700, which if you look at this, you can see there's a point. Shoot. Sorry about that. There's a point at 3,5,700. The slope we can calculate right here is the change in y, 5,700 minus 3,800, over the change in x, 3 minus 0, is approximately 633 feet. So therefore our slope is 633. Our point is 3,5,700, so x minus 3 plus 5,700, and the constraint is during the first 3 hours. The next part is lunch, and there's no gain or loss in elevation, so therefore it's the subfunction is just 5,700 for that entire hour, and that is from hour 3 to hour 4. The third part of it, you can see, is from the change in y is 67 to 5,700. It's 1,000 feet, and 5.5 to 3, that's 2.5 hours, and so or to 4, it's 1.5 hours. So there you can see it's approximately 667, rounding it to the nearest foot, per hour. So the slope is 667. The point is at 5.567, so it's x minus that plus that. It's from 4 to 5.5 hours. And finally, the last one that we see, the segment 4, it's going down, so it has a negative slope. So on segment 4, you can see the change in y is 3,800 to 6,700. The time is from 6.25 hours, or 6 hours and 15 minutes, to 5.5 hours. That works out to a negative 3,867 feet per hour. And there's our slope. The point is at 6.25, 3,800, that's in the parking lot, and that's from 5.5 hours to 6.25 hours. My calculations, which was number 3 for My slope and average rate of change is all given here as I went through. So the last one is just what's the speed, right? How fast are we going? And the total distance was 9, I should probably say miles. And the total moving time was 3 1/6 hours, because it's 3 hours and 10 minutes. So using a calculator, 9 divided by 3 1/6 is approximately 2.84 miles per hour. So that's the average speed, including uphill as well as downhill, for the trip.